x times x could be written as x to the power of 3 minus x times x could be written as s squared equal to 100. This means that x to the power of 3 minus x to the power of 2 equal to 100 could be written as 125 minus 25. This implies that x to the power of 3 minus x to the power of 2 is equal to 125. We can also write it as 5 to the power of 3 minus 25. We can also write it as 5 to the power of 2. Now, let's rearrange this equation. This means that x to the power of 3, when this comes to the left side, we have minus 5 to the power of 3 minus x to the power of 2. When minus 5 square comes to the left side, it becomes plus 5 square equal to 0. Let's continue. I can put these two guys in brackets. So that will be x to the power of 3 minus 5 to the power of 3 in brackets. I can also put these two guys in brackets, but I need to first factor out the negative sign. So that will be minus into x squared minus 5 squared equal to 0. Let's proceed further. At this stage, let's recall some beautiful properties. The first one is a cube minus b cube is equal to a minus b times a square plus ab plus b square. The second identity is the of 2 square. A square minus b square equal to a minus b times a plus b. Take note of these two identities. Now, let's first apply this identity to this guy. Doing that, we're gonna have x minus 5 times s square plus 5x plus 5 square minus. Now, applying this second identity to this guy, we're gonna have x minus 5 times x plus 5 equal to 0. You will observe that x minus 5 is common. I can pull it out, so that will be x minus 5 into this s square plus 5x plus, what is 5 square? That is 25. Close the bracket, minus x plus 5 equal to 0. Let's continue. X minus 5. Now, let us drop this square bracket. So we have s square plus 5x plus 25 minus times x, that is minus x, minus times 5 minus 5 equal to 0. X minus 5 times s square 5x minus x, that is 4x, 25 minus 5, that is plus 20, equal to 0. Let's continue. This implies that x minus 5 is equal to 0, or s square plus 4x plus 20 is equal to 0. From this line, it is obvious x is equals to 5. Let's call this x1. This is the first solution. Now, let us consider this quadratic equation. We can solve it using completing the square method by completing the square. The first thing we have to do is to transfer this constant to the right hand side. So that will be s square plus 4x equal to minus 20. The second step is that We're going to add half of the coefficient of x and at the same time square it to both sides. Coefficient of x here is 4. Half of it will be 4 divided by 2 and we square it. Add 4 over 2 all squared to both sides. Doing that, we have s squared plus 4x plus 4 over 2 all squared equal to the right hand side minus 20 plus 4 over 2 all squared. Let's continue. It is possible we can combine this left hand side. So that will be x plus 4 over 2 all squared equal to minus 20 plus 4 over 2 all squared. This means that x plus 4 divided by 2, that is 2, all squared equal to minus 20 plus 4 divided by 2, that is 2, so we have 2 squared. X plus 2 all squared equal to minus 20 plus, what is 2 squared? That is simply 4. This means that x plus 2 all squared equal to minus 20 plus 4, that is minus 16. Now, take square root of both sides. So that will be x plus 2 equal to plus or minus square root of minus 16. X plus 2 is equal to plus or minus square root of minus 16, equating as square root of 16 times square root of negative 1. X plus 2 equal to plus or minus, what is square root of 16? That is simply 4. And don't forget, from the complex number, square root of minus 1 is equals to I. So we have I here. This implies that x is equal to minus 2 plus or minus 4i. From this answer, we can obtain x2 and s3 respectively. S2 is equals to, consider the positive sign, we have minus 2 plus 4i. And S3 is equal to, considering the negative sign, we have minus 2 minus 4i. This is the second solution. Why this is the third solution? You will see that we have 3 distinct solutions for this algebra problem, 2 complex solutions and just 1 real solution, which is x1 equals to 5. That's it for this video.